Okay, I think we'll get started. Ladies and gentlemen, Joe Rao. Thank you for coming, Joe. Appreciate it so much.
Well, I appreciate the invitation. Thank you all for coming this evening. We're going to talk about. I build this talk as the science of astrometeorology. Maybe I should have called it the pseudoscience of astrometeorology because it's a very contentious issue. People ask sometimes about weather forecasting and whether or not it is possible to forecast by using the sun, the moon, even the planets. And that's what we're going to be discussing here at the Middle Country Library in the next hour or so. Now, from time to time, I will pause for 5 or 6 seconds. And that's not because I'm necessarily gathering my thoughts, but because I will be uh, sipping on some Poland spring water to help wet my whistle and wet my throat. So if you hear some pauses from time to time, you'll at least know what is going on. This is going to be a PowerPoint presentation. So what I'm going to do right now is I'm going to share my screen with all of you. I'll go to my slideshow here and start from the beginning. There we go. Now you should all be able to see on your screen the cover of a very important book if you're an amateur or professional astronomer, known as the Observer's Handbook. Now, if indeed you are into astronomy, this is a book that you need to have and need to get every year. This is a book that's put out by the Royal Astronomical Society of Canada. Its editor is James S. Edgar. In this book are all of the predictions for conjunctions between the moon and the planets. In other words, when the moon is going to be near to a planet in the sky, this book, this handbook, will tell you all about it. If there's going to be an eclipse coming up in 2022, and we do have a couple of them that will be visible from the tri-state area of the moon, and they're both going to be total eclipses of the moon, you'll be able to get all of the exact times from this book. If there's a comet that might become bright enough to be seen, or perhaps a meteor shower that is going to take place, you can be guaranteed that this book will have it. The interesting thing about this book is that it is absolute. Take, for example, the eclipses. I can tell you with absolute certainty that on the night of May 15th at about 10:30 p.m., not even at about, I don't have the book in front of me, but let's say 10:31 p.m. Eastern Daylight Time, the moon will begin to enter the shadow of the earth and start the beginning of a total eclipse of the moon. That is definite. There is no ands, if, or buts. That is going to happen. As I said, everything in this handbook is important to astronomers because they know that when they pick up this book and look at the celestial schedule for the upcoming year, you can count on everything more or less being precise and occurring to the exact moment. Sunrise, sunset, moonrise, moonset, everything is in this book. And I look at a book like this and I say to myself, wouldn't it be wonderful? Wouldn't it be great? And I'm sure you may have thought this too. If we had a book that could tell us that type of information with absolute certainty and surety, what the weather is going to be like on any given specific day. Wouldn't that be wonderful to have? Well, guess what? We do. I guess there are two different publications that come out each year. They usually appear in the latter part of the summer, August and September, and they are the Old Farmer's Almanac and the Farmer's Almanac. Now, the Farmer's Almanac has been publishing continuously since 1818. Wow, that's been a long time. I think this year was their 204th edition. And yet, the Old Farmer's Almanac, and this is why they call it the Old Farmer's Almanac, because it is a bit older, they have been publishing since 1792. Could you imagine? I mean, these two publications have been around for over 200 years. And each publication has in its pages weather forecasts for the upcoming year. So if you want to know what it's going to be like on the 4th of July, if you're going to have a 4th of July picnic or barbecue planning now, look in the Farmer's Almanac or the Old Farmer's Almanac and check out what their weather forecast is for that. Of course, both almanacs forecast the weather somewhat differently. And I'm sure that if you looked at one almanac and it said, for example, for March 17th, St. Patrick's Day, maybe one would say it's going to snow that day, the other would say it's going to rain, or maybe it's going to be sunny. But the question is, how do they do that? How do they make these predictions? I mean, in some cases, it's difficult enough. Take, for example, the storm that purportedly was going to come this way during the weekend. Back on Monday, they were saying there would be a big snowstorm. Now we know that probably is not going to occur. But, they thought it was going to be here on Monday. And now 2 days later, they're saying, no, it's not going to happen this weekend. There's a big flip in the forecast, a big change in the forecast. Sometimes these weather forecasters can't even tell what it's going to be like 2 days in advance. And that these two publications say, we'll predict the weather for the next year. And all you need to do is buy it, look it up, and we'll have. Now, they don't say they're 100% accurate. Depending upon which publication you get, the Farmer's Almanac, the old Farmer's Almanac, they say they have an accuracy of about 70 to 80%. Now, I myself have never done a test as to what the almanac accuracy is, but people still buy this almanac or the old Farmer's Almanac after all these many years. So I guess there must be some certain high percentage of accuracy with it. They're very popular publications. But how do they do it? Well, maybe just maybe they're using the cycle of the moon. Does the moon have any influence on our weather? Some people believe so. Others say, nah, not really. It's interesting that way back in the year 1834, a gentleman, by the name of Dr. Herschel, published a table. And this table appeared some years ago in the old Farmer's Almanac. It says that this table is the result of many years' observation and shows what sort of weather probably follows the moon entrance into any of its quarters. And they also point out, or at least as I said, this was the old Farmer's Almanac. They said, while the data in this table are taken into consideration in the year-long compiling of the annual long-range weather forecast for the old Farmer's Almanac, they rely more on their projections of solar activity. So for the old Farmer's Almanac, they apparently use solar cycles, and we'll get into that a little bit later in this talk. But for example, we had a full moon the other night. In fact, the moon officially turned full on Monday night at about 6:50 p.m. Okay, so let's talk about this. The change took place at around 6:50. So the time of the change, the time when the moon officially became full, fell in this time frame, 6 p.m. to 10 p.m. Now, if it was the summertime, we would read this as a forecast for fair skies if the wind was from the northwest. But if the wind was from the south or southwest, we would expect it to be kind of wet, maybe some rain. We're into the winter, obviously, so let's see what that said. Fair and frosty if the wind is north or northeast. Rain or snow if the wind is south or southwest. What did we have on Monday? Well, what did we do? We had snow and rain. Well, actually, on Long Island, I'm talking to a group now. All of you are from Center Reach or in the vicinity of Center Reach. So you were mostly rain as opposed to snow. Up where I am here in Putnam Valley, New York, we had snow changing to rain, but it was kind of a mixed bag of unsettled weather. And the winds were out of a northeast direction. And they said, well, if the wind is north or northeast, it would be fair and frosty. I can assure you it was not fair and frosty on Sunday night and Monday. But it did turn into the south, the winds did, and then it changed over to rain. So shifting wind, I don't know. If you really and truly believe in this table, you could pin it up on your refrigerator or whatever, and you can look at it when the moon changes from full to last quarter or new to first quarter or whatever, and see how accurate this is. Again, this table appeared or was created more than 160 years ago, first appearing in the old Farmer's Almanac in 1834. So the moon, one way of trying to make predictions. Now here's a gentleman who is of some noteworthy historical past. His name is Elias Loomis. He was not a meteorologist. He was an American mathematician who lived in the mid to late 19th century. Isn't this kind of like a learned scientist or an individual? You would expect somebody with a scientific background to look something like this, with this distinguished looking face and the beard. And I mean, if this, Elias Loomis seems like the perfect name for somebody who looks something like this, right? Well, anyway, he wrote a book, a treatise on meteorology, a very thick volume on meteorology in 1868. He, again, was not really a meteorologist, but he studied all kinds of stuff, northern lights displays. He was, again, a mathematician. One of the things that he wrote in that book on meteorology that he wrote in 1868 is that the atmosphere is very much like the ocean. He said there's a lot of fluidity, and that the moon, in its movement around the Earth, has a reaction, or the atmosphere has a reaction to the movement of the moon. He pointed out, look, we could predict when tides are going to occur because we know the movement of the moon and its tidal effects on the water and on the oceans. And we were able to tell when the tides are going to be at high stage or high tide or low tide. And he said that if we were able to forecast the situation regarding the oceans using the motions of the moon, most certainly we should be able to do the same thing in terms of our weather, because the atmosphere acts very much like the ocean. And there are tides in the atmosphere, like on the ocean. Well, if you were to ask a meteorologist today about that, the meteorologists of today would probably scoff and say, well, maybe, but there's no big deal. It's the influence of the moon on our atmosphere is probably very, very slight, if anything at all. Well, take a look at this picture. This is a picture of clouds, and what we have here are something known as Kelvin Heimholz clouds, or billow clouds, or shear gravity clouds. And they occur, it's a very rare type of cloud, but when they do occur, they occur during times of different air densities. In other words, for example, you may have heard from time to time about the terminology of an atmospheric inversion. When it's actually warmer, it's normally colder as you go up into the atmosphere, but sometimes a layer of warmer air overruns a layer of colder air down by the surface where you and I happen to be. So the atmosphere gets churned up a bit, and sometimes during that churning, you get something like this. And look at this. This really and truly looks, doesn't it, like waves on the ocean? But I'll show you something even more dramatic. Take a look at this. This is a video taken from a high mountaintop in Europe. And you've heard of the term overcast when it's cloudy above you. This is from a high mountaintop looking down at the clouds. But look at the clouds. Look at them. My goodness. It looks just like waves on a beach. That's really amazing, isn't it? Maybe Elias Loomis had something when he said that the atmosphere is fluid, that the atmosphere does react sometimes like an ocean. My God, look at that. It looks like almost like waves lapping onto the surface of a beach. And is it possible maybe that indeed the moon can be used to forecast the weather? Now, today, this is what I think meteorologists think about when they're asked about this question. The moon and I don't know exactly who wrote this. It's a limerick, and the limerick is anonymous. But it's a funny enough limerick to share with you here on this topic or subject. The moon and the weather may change together, but change of the moon does not change the weather. If we had no moon at all, and that may seem strange, we'd still enjoy the weather that's subject to change. In other words, if we didn't have the moon, we'd have weather, and the weather would change. But can we think of the moon maybe as a way of controlling the weather? And if we knew about the way that the moon controls the weather, can we use that to try to forecast the weather in the future based upon its future movements? Now, this man that you see here probably is not familiar to any of you, but at one time, for 1 year, in the year 1966, he was on television here in New York every night. His name is Harry Geiss, and Back in the mid 60s, there was a change going on in television weather casting. You see, up until about, I'd say 1965, if you turned on your TV and looked at the weather forecast, most of the TV stations in this area had women doing the weather. And the women were not necessarily meteorologists, but they were attractive, and they were able to communicate to you about what it was going to be like tomorrow. For the next day, I remember as a very young boy on Channel 2, for example, back in the early 60s, watching a young lady by the name of Carol Reed. And I remember Carol Reed used to always end her weather forecast the same way. She'd always look into the camera after the forecast was done, and she'd smile and say, "And have a happy." That was her end line. Have a happy. I remember watching on Channel 11. I used to watch Channel 11 a lot because the cartoons they used to have were hosted by Captain Jack McCarthy and Officer Joe Bolton. And for their weather girl, they had Gloria Ocon, it was sponsored by Arnold Bread. And she used to sing the Arnold Bread song after she did the weather forecast. She was a very popular person. These were popular women back in the early 60s and even the 1950s. But in 1965, something happened. In 1965, Channel 4 here in New York got Dr. Frank Field, a accredited scientist and meteorologist. And Channel 4 said, "We're done. We're from now on, you're going to get the weather. You're going to have radar. We have a true scientist who's going to tell you what the weather is going to be like." Well, Channel 2 said, "Well, wait a minute. We can't let this happen. We can't let our competitor have a real scientist." So they got rid of Carol Reed, much to the chagrin of many New York TV viewers, and they brought in this guy from California, Harry Geiss. Harry Geiss was interesting because he not only gave you the forecast in the short term, he gave the forecast in the long term. He was famous in California for making long-range forecasts, and Channel 2, and as soon as they brought him in, said, "Harry, do your stuff. Give us an amazing long-range prediction." And during the Columbus Day weekend in 1966, Harry Geiss came on television, looked into the camera, and said, "I am predicting that we're going to have a big snowstorm here in the Northeast and here in the New York metropolitan area on Christmas." He was promising a white Christmas, but not just a few snowflakes. He was promising everybody a big snowstorm for Christmas. And it wasn't the fact that he just mentioned that Columbus Day weekend. He mentioned it also whenever there was a holiday, Veterans Day. He would say, "It's a holiday, make sure to put the flag out today in honor of our veterans. And by the way, I want to remind you, a big snowstorm is coming Christmas." Thanksgiving, he talked about, well, the Christmas holiday season is opening. People are buying things now and everything else. But buy everything now before the Christmas rush because it's going to be tough. We're going to have a big snowstorm right around Christmas. He kept egging this on, kept telling it. And, it got to the point where he said, "Who is this guy to forecast with such surety and certainty? Nobody can forecast the weather that far in advance with such certainty as that. Nobody can." Whoop. Look at this. Here is the weather map, the post-mortem, if you will, for Christmas, December 23rd to 25th, 1966. Look at this now. In the areas of white, that was, you see the legend here? That's where 4 to 10 inches of snow fell. That included Long Island. That included the New York metropolitan area. Some of you might want to ask your parents, do you remember 1966? That Christmas Eve, I remember, got very excited. Not only did it snow, we had thunder and lightning. It is known now in weather annals as the Donner and Blitzen snowstorm, 1966 Christmas Eve into Christmas morning. And look at the shade of dark blue, 10 to 20 inches. And this deep, deep shade of blue, 20 to 30 inches of snow. And the question is, this was predicted by Harry Geiss back in October, for goodness sake. He promised. He didn't lay off, and he just said, this is definitely going to happen. And it did. Look at the front page of the New York Times. This was Christmas morning. "Snow brings city white Christmas. Travel snarled. Emergency declared." Yeah, well, Harry Geist was right. Look at this. These are two Christmas shoppers on Christmas Eve. They don't look very happy having to do their last minute shopping in snow and cold weather. But again, this was forecasted by Harry Geist. How did he do it? Well, one way that, and I will tell you that he did reveal his secret to one person. We're going to get to that in a little bit. But he left a lot of people wondering, scratching their heads. Well, how did he do it? How did he forecast the weather? Maybe he used the moon. What kind of lunar cycles could he have possibly used? Well, there's the Metonic Cycle. The Metonic Cycle is a period of 19 years or 235 lunar months, after which the new and full moons return to the same days of the year. And it was the basis of the ancient Greek calendar and is still used for calculating movable feasts, such as Easter Sunday. Maybe he used the Metonic Cycle. For example, we had a full moon on Monday night. What was Monday night? That was January 17th. Do you know that 19 years from now, this is what, 2022, so in the year 2041, on January 17th, you know what we're going to have? We're going to have a full moon. Same date as the one that we had this week, January 17th. Every 19 years, the moon returns to that same part of its orbit, allowing it to once again have the same phase. 19 years ago, this is what, again, 2022. So in the year 2003, there was a full moon on January 17th. So if that be the case, if the moon returns to basically the same spot in its orbit every 19 years, maybe Harry Geist used the Metonic Cycle. Maybe 19 years earlier, from 1966, in the year 1947, around Christmas 1947, we may have had a big snowstorm. Did we have a big snowstorm? Christmas 1947? Oh boy, did we have a big snowstorm. Look at this. Record 25 inches of snow crippling New York City. All traffic slowed. Thousands marooned. It was in fact, for the longest time, the biggest snowstorm ever recorded in New York, until we had a bigger one back in 2016 where we had like 27 inches of snow. But it was the biggest snowstorm since the famous blizzard of 1888. Well, there you go. There you go. There's Harry Geist's secret. He used the moon and he used the Metonic Cycle. So every 19 years, we could expect a big snowstorm, right? Well, let's see. If that be the case, 1966. So how many of you remember the big snowstorm of Christmas 1985, 19 years later? The big snowstorm of 1985. Do any of you remember that? You don't. And you know why you don't remember it? Because it never happened. In 1985, there was no big snowstorm, either on Christmas or the day before or the day after Christmas. Nothing. So the 19-year rule, the Metonic Cycle for weather forecasting, doesn't seem to work. Or maybe it does, but it has to work in conjunction with another lunar cycle. So what other lunar cycle might there be? Well, here's a picture of the full moon, and you can definitely notice that there is a difference between the moon on the left and the moon on the right. The moon on the left was a full moon taken at the time when the moon was at perigee, apogee. Apogee. That's the moon on the left. Apogee is when the moon is at its farthest point in its orbit relative to the Earth, about 252,000 miles away. Now, the picture that you see on the right was taken of a full moon when the full moon was at perigee, closest to the Earth, 221,000 miles away. There's a difference between the two of roughly 14% in terms of size and in terms of distance. So the moon can be rather far or it can be rather close. But if you think about it, it seems in our sky over a span of many months to pulse in size, getting bigger and smaller. And it's a function of how far away the moon is relative to the Earth. Could this have a say in forecasting by using the moon? Well, this man believed it did. This man is Stephen Martin Saxby. He lived in England during the middle and latter part of the 19th century. And Saxby, in looking at the lunar tables, made a prediction about the moon and its relative influence on our planet and on our weather for October of 1869. He had determined that the new moon was going to be at perigee, the closest point to the Earth. And also, this was going to happen when the moon was going to be crossing the equator. And he wrote a letter to the local newspaper, the Standard of London, predicting that at the time of new moon in 1869, October the 4th of that year, there was going to be major cataclysmic flooding, major storm that would take shape and take form in response to the new moon at its closest point to the Earth, perigee, as was crossing the equator. Well, in the aftermath of that letter, people flooded the Standard of London with questions. Dr. Saxby, and he wasn't even a doctor. Everybody just automatically assumed that he was a doctor or a professor. Dr. Saxby, Professor Saxby says there's going to be a big storm on October 4th. But where is this big storm going to be? Is it going to be here in our homeland of England? Or is it going to be across the sea, across the big pond in the United States, or maybe somewhere else in the world? Where is this going to be happening? Please ask Mr. Saxby, Dr. Saxby, where this supposed big storm is going to be relative to the time of the new moon in October of this year. So Saxby, the newspaper, got back in touch with him and said, you have to answer this question. You have to answer these people. What is the answer to this? And Saxby wrote back another letter to the Standard of London. If this isn't an open-ended answer, I don't know what is. He said the warnings apply to all parts of the world. In other words, this storm could appear anywhere on the surface of the Earth. Its effects may be felt more in some places than in others. And then he kind of must have shaken his head and bowed his head and said, it is painful to have to forebode evil, but better thus than to merit self-reproach under circumstances which might lead to permanent regrets. Could I save just one life, it would be very cheaply purchased in making better known certain laws of nature. Again, this was a letter to the Standard of London. This was about 2 weeks before the big tempest in September of 1869, September the 16th, 1869. So basically, he said, this is a storm that could appear anywhere in the world. And how many storms on any given day in any part of the world? There are big storms, there are summer times, there are hurricanes and tropical systems or whatever. So really, if you don't mind me saying so, this prediction was a BS prediction. The only thing that could have happened or would happen is that wherever a storm occurred, the combination of the storm, especially out over the oceans, in response to the perigee of the moon closest to the Earth, when the moon is rather close, high tides run exceptionally higher than normal, which could lead to coastal flooding, beach erosion, whatever. But you have to have a storm for all of that to happen. If you don't have a storm on the given day, you'll have some higher water, but that's about all. But this was not really a forecast for a specific area for a specific storm. But somebody took it one step further. The gentleman you see here is Frederick Allison. Now, Frederick Allison is an interesting guy. He wrote about weather conditions, past weather, in a weekly column that he wrote for the Halifax Evening Express. This is in Nova Scotia. So normally when he wrote about weather, it was about, well, the storm that we had last week or the storm that we had last month, or you remember that system that we had a couple of years ago, or the anniversary is coming up this week. That's what he usually would write about. But somehow or other, he got hold of the prediction by Stephen Saxby. And he said, is this possible? Maybe. And I think Mr. Allison thought that he would try to make a name for himself, thinking that perhaps there could be a storm in Nova Scotia on that date of the time of the perigee new moon crossing the equator. Mr. Allison wrote in his column, and this was about a week before the purported storm. This was written in the Halifax Evening Express, October 1st, 1869. He wrote, I believe that a heavy gale will be encountered here on Tuesday next. That's the 5th of October. Beginning perhaps on Monday night, perhaps deferred to as late as Tuesday night. But between these two periods, it seems inevitable. In other words, he's saying there's no backing away from this. There's going to be a storm Monday or Tuesday of next week. Roughly speaking, the warmer it may be on the 4th, the more violent will be the succeeding storm. Apart from the theory of the moon's attraction as applied to meteorology, which is disbelief by many. In other words, Allison is writing in this text here, he's saying that apart from the fact that the moon's attraction does have an influence on our weather, which many people do not believe, the experience of any careful observer teaches him to look for a storm at the next new moon. Now, he wrote this on October 1st. He's calling for a storm on October 5th. Now, you know that in today's society, you could turn on and you could watch Lonnie Quinn on Channel 2. You could watch Lee Goldberg on Channel 7, or Nick Gregory on Channel 5, Mr. G on Channel 11. You can watch all of them, and you'll get a forecast for the next 5 days, even perhaps for the next 10 days. They do that on Channel 4, a 10-day forecast. Well, that's all right. I mean, you got the technology to do it. Go ahead, do it. You can make your forecast for 5 or 10 days in advance. Not necessarily that it's going to be right. I mean, my goodness, on Monday, they were telling everybody about a big storm this Saturday. Now we know a few days later, that ain't going to happen. But still, people like to see a 5-day. But now, here's Frederick Allison making a forecast for 4 days in advance. But Frederick Allison did not have computer technology as we have. He did not have a radar at hand like we do. He did not have a satellite, a weather satellite, to look down and see whether he was making this prediction based upon the Saxby prediction. He was making a prediction based solely on the moon, its closest to the Earth, its passage over the equator. That's all he was doing, was making a prediction for a storm. Remember, Saxby was making a prediction for what might happen if a storm did take place, knowing that if a storm took place along coastal regions, that the tides would be higher, there'd be beach erosion, flooding, etc. He wasn't really predicting specifically a storm. He was just saying, wherever in the world there's going to be a storm, that's where the problems are going to be. Allison was saying, no, this means we're going to have a significant storm. And you know what? Lo and behold, when he issued this prediction on October 1st, there was a hurricane. There was a storm, probably a Category 2 or maybe even a Category 3 storm, located off the southeast coastline of the United States. And that storm, over the days ahead, tracked to the north and northeast. It crossed over Cape Cod. It made landfall in coastal or down east Maine, and then continued into New Brunswick and the Gaspé Peninsula of Quebec, Canada. And everybody on the right-hand side of the storm, and that's the worst place to be in a tropical system, in the right section of the hurricane or tropical storm, that's where the winds are fiercest. That's where the rain will be coming down the hardest. This is the worst spot to be relative to a tropical system. And in Nova Scotia, in Frederick Allison's homeland, there was tremendous destruction. They still talk about it today, at that big storm that occurred in early October of 1869. And the storm was not called Allison's storm, even though Frederick Allison made this outlandish prediction based upon what Saxby had wrote. Everybody today thinks of this not as Allison's storm, but as the Saxby storm or the Saxby gale. Now, in 2001, I wrote an article for WeatherWise magazine. Now, by the way, if you have any interest whatsoever in weather, I strongly urge you to subscribe to WeatherWise magazine. You could probably find it on the web. Just type on Google WeatherWise magazine and you can get all the information on how to subscribe. Thousands of amateur and professional meteorologists read this. You get 6 issues a year, comes out bi-monthly. And again, the meteorologists, weather geeks and fanatics read this magazine. In October of 2001, the October edition, September, October of 2001, I wrote a feature article called Moonstruck Meteorology. And I asked, is it lunacy to think that Saxby's Gale could recur in October of 2001? And why would I write something like that? Because using a computer software. By the way, it's wonderful the technology we have today. You go to the Hayden Planetarium or the Vanderbilt Planetarium in Centerport, and they use that magnificent projector to project and show you the skies, how it would look tonight, or how it'll look hundreds of years in the future or hundreds of years in the past. You don't need to do that. You don't need to go to a planetarium anymore. You can put planetarium software on your computer, and you could watch on your computer monitor. You can roll forward in time, backwards and forwards. And using computer software, I looked at the circumstances of the moon in October of 1869, and then I looked ahead and found that the circumstances, the new moon was going to be in virtually the same position at perigee, moving over the equator, virtually the same circumstances that was occurring when Saxby had wrote that letter to the London Standard back in 1869. So I wrote, is it lunacy to think that Saxby's Gale could occur this year in the year 2001? I mean, if there's anything to this forecast, if there's anything to the moon's attraction on our weather, would this indeed have a say in creating some kind of a significant tempest, a significant storm? And I didn't just base it just on the Saxby Gale. There were a couple of other times when this same circumstance came up, when we had a moon either at full or new, at perigee, crossing the equator. And in those, well, I'll give you an example. Here is, and of course also, there have been cases, ancient mariners, around the time of both the vernal and autumnal equinoxes in March and September, always used to say that when the sun crossed the line, when the sun crossed the equator, there was always some kind of a significant storm that rumbled up or took place. And the example right here of ships that are being shipwrecked or wrecked by the tremendous waves. Okay, one of those two dates that I found in using computer technology, looking backwards in time, was on March 22nd, 1967. We had a full moon, and we also had the moon at perigee, closest to its to Earth in its orbit. And at that same time, the moon was right over the equator. Here's the forecast that was issued by the U.S. Weather Bureau, now called the National Weather Service. This was from the New York Times of that day. Mostly cloudy, with a few snow flurries likely, and then clearing in the evening or tonight. High today in the upper 30s, low tonight near 30, fair and seasonable tomorrow. That was the forecast for March 22nd, 1967. Do you want to know what happened on March 22nd, 1967? Bingo! Yeah, they had flurries. They had 10 inches of flurries that surprised the city, clogged the roads, caused precarious walking, a spring snowstorm that surprised the metropolitan area. Take a look at this. This gentleman you see with this big smile in his face, I wouldn't be smiling. That was Anthony Tancredo. He was the head of the he was the, again, we call it National Weather Service, back then Weather Bureau at Rockefeller Center. And he agreed that yesterday wasn't one of his better days. To put it mildly, he and his staff were caught with their snow boots not on. Normally, one forecaster at the weather office said, normally a storm like this would give us little or no snow. As one meteorologist said, like a man trying to explain to his wife why he hadn't phoned when he missed the train. Anthony Tancredo, the meteorologist in charge, said he was right only most of the time. And he likened Tuesday, Wednesday's forecast to good surgery that does not turn out well. The operation was successful, but the patient died. The storm that had been predicted for that day to bring just a few flurries, minor storm, turned out to be a storm that got much stronger, much faster than anyone had anticipated, and dumped all of that snow on New York. Now, that was one case of the moon possible influence on our weather. What about the other case? The other case also happened in March. On March 12th in the year 1993. Here it is. This was known as the storm of the century. This was the superstorm. We talk about Sandy, Superstorm Sandy. Sandy was a storm that affected our area and adversely caused problems. This storm truly was, though, a superstorm. This storm brought heavy snow from New England all the way down to Birmingham, Alabama. It created a squall line with tornado-producing thunderstorms across the Carolinas and across Florida. This was truly a major, major storm. And in fact, the front page of the New York Times talks about storm paralyzing the East Coast. Storm snow covers the South, 33 killed. This again, all coinciding with a new moon, with a full moon at perigee, closest to the Earth, and also crossing the equator. That's a very important thing to note. Very important, because each year we have the moon either coming to perigee at full or at new phase. That happens every year, at least twice a year. But you have to have a very special scenario for it to be over the equator at that moment when it's turning full or new, and also when it's very close to the Earth. Whether or not this is something that Saxby had recognized when he made that prediction, or he wrote that letter back in 1869. Anyway, I asked the question in Weatherwise, can this happen again? Because it was going to happen in October 4th and 5th in 2001. And so I asked everybody to watch and look at this. Look at this. A hurricane, Hurricane Kyle, which was out in the ocean. Here's Puerto Rico, the Dominican Republic. It's the Atlantic Ocean. Up here, we have the mainland eastern seaboard of the United States. This is where Kyle was in September the 26th. I saw this and I said, whoa, where is Kyle? Is Kyle going to be a repeat of the Saxby Gale? Now, we know from climatology that when you have hurricanes in late September, they usually take one of several different paths. A track that sometimes could take them, let's say, south of Puerto Rico and the Dominican Republic into the Gulf of Mexico. Or sometimes they take a track a little bit to the north of Puerto Rico up into Florida and the Gulf of Mexico. Or sometimes they just seem to wind on a path up close to the coast. They might actually sideswipe the coast, or then they curve away from the coast. Is this what Hurricane Kyle was going to do as we got closer to October 4th? I now want to show you the path of Hurricane Kyle. And this had to be one of the wackiest, weirdest paths that I have ever seen in all of my years of forecasting. Not only was it a long-lived storm, here, by the way, is Bermuda. They must have been shaking because this storm was like in the vicinity of Bermuda for days. But look at this. It was almost as if Kyle was drunk. First, it went north, then it made a loop and headed southwest. Then it headed west-southwest. And then it turned to the northwest, continued to turn to the northwest. And then it looped again, made a little loop here, then went back to the southwest, and then curved near Florida and along the Carolina coast and moved off, and finally died out somewhere off the mid-Atlantic. Have you ever seen this? I've never seen a path like that. This is a crazy path. Now, what could have caused that? Could it have been the moon? Could it have been the fact that it was at perigee? Could it have been that because it was over the equator that it was reacting to the influence of the moon? I don't know. The upper level winds are usually what drives hurricanes and tropical systems across the oceans. But this was, again, one of the weirdest looking paths that we have ever seen in recent years. And it all coincided again with that period when the moon was at an unusual closeness and passing over the equator on Earth. Now, we talked about the moon. How about the sun? Remember back at the beginning of this session, I mentioned that the old Farmer's Almanac said, the sun, we rely on the sun and solar activity to make our predictions. Well, the sun is very important. Without the sun, without its heat, without its light, we wouldn't have any life here on this planet. Interestingly, though, during periods, during cycles, we have times when the sun has spots on it, sunspots. And they appear darker than the surrounding surface of the sun. Actually, the reason why they are so conspicuous These are magnetic storms, cooler magnetic storms that roam across the sun's photosphere, the sun's surface. The surface of the sun is 11,000 degrees. These solar storms, these sunspots, are about 3,000 or 4,000 degrees cooler than the surrounding areas, and that's why they appear dark relative to the rest of the sun's surface, sun's face. Mark my word, though, if you were able to somehow lift a sunspot off the surface of the sun and put it up against the sky, it would shine dazzling. It'd be hundreds of times brighter than the full moon. But because, again, of that difference of several thousand degrees, these solar storms appear dark against the sun. And interestingly, also, they come and they go. There are quite a few sunspots during intervals every 11 years on average, the Sunspot Cycle. And in between those 11 years, there's a period when there's a quiet period on the sun, when no spots are visible. And we call that Sunspot Minimum. Now, here you see the Sunspot Cycle. We've been charting this. This is from the 20th, during the 20th century. And if you'll notice, again, at 11-year intervals, the sunspots seem to peak, and then very quickly they drop off, and then they go back up, and then they drop off, up and down, up and down, up and down. That's the Sunspot Cycle. And here's a gentleman. His name is John Eddy, and John Eddy studied solar cycles. He was into sunspots. He talked about, he studied sunspot records. Sadly, Dr. Eddy died in 2009, but he did a whole lot of research on sunspots, not only modern observations of sunspots, but sunspots that were visible for hundreds of years in the past. One of the things that he took note of was the observations of this man. This man is Edward Maunder, and he lived and did research on sunspot activity around the turn of the 20th century. Maunder noted that between the years 1645 and 1715, there was a paucity of sunspots. No sunspots which were occurring around that period of time, which Dr. Eddy said, that's ridiculous. We've always had sunspots. They come at 11-year cycles. How could there not be sunspots for so long length of time? Dr. Maunder must have been crazy. I don't know where he got this information. So Dr. Eddy did his own research, and you know what? He verified what Maunder said, that there was a period between 1645 and 1715 where there were no sunspots that were visible. And then he stumbled across something else, the record of another scientist, a German by the name of Gustav Sporer, who lived in the mid to late 19th century. Sporer said there were no sunspots between the period from 1420 to 1570, that there was a minimum or a lack of any sunspots then. Wait a minute. How could he have said that? You see Sporer here looking very dignified. Didn't I tell you that, people who lived back in the day, distinguished scientists, they always had that distinguished looking look and the beard. That was very important. But how could Sporer make that claim that there was a lack of sunspots between 1420 and 1570? How could he say something like that? The telescope wasn't invented until 1610. Galileo made the first observations of sunspots shortly after he built his first telescope. So how could Sporer say that there were no sunspots in the 14 or 1500s? He said that because he was a dendrochronologist. A dendrochronologist, what was that? That is someone who studies tree rings. And you could see that when the tree rings, in this particular case, appear very wide, that seems to indicate that the tree was growing fast and freely, that there must have been some rather warm weather and maybe some rather moist weather occurring. And then when there were times when the tree rings didn't show much of a change from year to year, when they were closely packed together, that seemed to indicate that the weather was colder and drier. And that's what he based that on. Because Sporer said that during periods when there were no sunspots or a few sunspots, the weather tended to be cold. And when we had a lot of sunspots, the weather warmed up. Hence his reasoning by studying tree rings that there was no sunspots during that period from 1420 to 1570. And another person, a meteorologist who lived in England, John Dalton. He was a chemist, he was a physicist, he was a meteorologist. And John Dalton said that there was a period when there was not much in the way of sunspot activity from 1790 to 1830. No sunspots, or hardly any sunspots. And again, Dalton pointed out the fact that it was unusually cold during that time span. During these periods, for example, from 1645 to 1715, the so-called Maunder Minimum, pointed out by Edward Maunder. Look at this. In Scotland, the lakes froze. The Thames River in England froze. That rarely ever happens, but it was an unusual period when there was, I guess you could call it, global cooling. And these people, Maunder, Spora, Dalton, all attributed it, and Eddy to a degree too, to the lack of any sunspot, the lack of any solar activity. And here's something that stays with us even to this very day. When you read Dickens' Christmas Carol, or maybe you've seen it on television, done by a variety of different actors, Alastair Sim, George C. Scott, Mr. Magoo, for goodness sake. What is the setting that they have? It's in England, and it's always the same thing. It's cold, it's snowy. Well, if you go to England today around Christmas time, it's not cold, it's usually quite mild, and it very rarely snows around Christmas time in jolly old England. But back in early 1800s, when Dickens wrote his story, it was cold, it was snowy and flaky most all the time around Christmas time. And that was the period that John Dalton was making reference to for the lack of any sunspots, the so-called Dalton minimum, again, from 1790 to 1830, encompassing the time when Dickens wrote his Christmas Carol. Now, is there any connection between solar activity and climate? Zarkova, a Russian scientist, wrote, along with a team of other climatologists in 2015, he pointed out that there was a period, a medieval warm period, when there was lots of sunspots. Then came the so-called Maunder Minimum and the Dalton Minimum, the little ice age, so to speak, when there were very few sunspots occurring. Then we have what he calls the modern maximum, where during the most of the 20th century, especially during the 1950s, 60s, and 70s, we had lots of sunspots, double peaks occurring at, again, the 11-year intervals. And now, according to Zarkova, we should prepare for global cooling, because he says that solar cycle 26, we're into solar cycle 25 right now, right at this moment. But when solar cycle 26 comes in the mid 2030s, that is going to be the end of the modern sunspot maximum. And we will not have much in the way of solar activity and sunspots, and we will go into a period of global cooling. And that is what Zarkova is predicting. He points this out too. Sunspots are weakening. Look at the peak of the sunspot activity back in the 1980s. We would expect the sunspot number at the peak to be about 250 or thereabouts. And then when the next sunspot cycle occurred in the early 1990s, the sunspots, the maximum was not quite as high. It was down to like 200. And notice, if you will, it goes down even more so in the early 2000s. And the last sunspot maximum, which actually was delayed, it was not an 11-year cycle, it was more like 12 or 13. The sunspots were the fewest we had seen in over a century. And Zarkova is saying that this is going to continue this downward trend through this cycle and into the next cycle, a decade from now. And after that, no more sunspots for a while, no more solar flares, and it's going to turn cool. That's what he says, Zarkova. Well, already there's a problem with this, because already we're seeing that this solar cycle, number 25, is already providing us with far more sunspots than the previous cycles at this point in the solar activity scale. So yeah, this is supposedly what we're going to be dealing with mid 21st century, of lack of any sunspots and a spell of unusually cold weather here in the northern hemisphere. But this man says hogwash, or as I guess Colonel Potter on MASH would say, horse hockey. Well, he wouldn't say that. This gentleman, the man that you see on your screen right now is Gavin Schmidt. He is a climatologist, a climate modeler, and a director of the NASA Goddard Institute for Space Studies in New York, right here in New York. And he says that those who claim that sunspot activity is connected to climate and weather don't know what they're talking about. Well, maybe he's taking a swing at the old Farmer's Almanac, because that's how they apparently make their forecasts, using sunspot activity. So I had the honor of interviewing this gentleman when I worked for News 12 Westchester as their chief meteorologist and science editor about 10 or 12 years ago. I visited him at the when he was giving a talk at the Hudson River Museum. And I asked him, I said, Dr. Schmidt, is sunspot activity connected to climate? No, absolutely not. I said, well, Dr. Schmidt, then how would you explain the fact that the so-called Maunder Minimum, the paucity of sunspots that occurred back in the 16 and 1700s, coincided with the Little Ice Age and the Dalton Minimum and the Spora Minimum? How could you explain all of that? And he said, the reason is simple. During that time frame in Earth's history, there were a lot of volcanic eruptions. And we just had a big one on the island of Tonga. Maybe you heard about that last Saturday. Punched a hole in the atmosphere up to 100,000 feet into the stratosphere. And according to Dr. Schmidt, we had a lot of those kind of volcanic eruptions during the 17th and 18th century, putting a lot of dust, a lot of ash, an aerosol cloud of sorts that went up into the atmosphere, covered the northern hemisphere for years on end. And when that happens, the light from the sun hits that cloud of debris and bounces back into space. It reflects the light of the sun and prevents some of the heat and light from reaching the Earth. And as a result, according to Dr. Schmidt, we saw a cooling of the atmosphere. This was especially so, he said, in 1815. Tambora, one of the most devastating volcanic eruptions ever in this planet's history. Tambora, which sent a tremendous cloud of ash, a tremendous aerosol cloud up into the atmosphere, covering the northern hemisphere. And in the year after the eruption of Tambora, here in the United States, in New England, 1816, the year without a summer. In 1816, not only were temperatures well below normal, but in parts of New England, it snowed every month of the year, in June, July, August, September. And that supposedly, that 1816 eruption occurred, 1815 eruption occurred right smack in the middle of the Dalton Minimum. Remember, I talked about the influence of the weather in England, the Dickens' Tale of a Christmas Carol. That, said Dr. Schmidt, is one example of what volcanoes can do and how they can change. Nothing to do with sunspots, nothing to do with solar activity. It was volcanism. And of course, that's a very contentious issue. There's still people who believe in sunspots, people who believe in volcanoes. Again, it's up to the person who's doing the research as to what is actually happening. Now, here's another question. Can planets affect our weather? Now, I personally don't believe that is possible. How could a planet, even a large planet like Jupiter, a very massive planet, how could that affect the weather or even affect the Earth as a whole? We're millions and millions of miles away, 500 million miles away from Jupiter, and yet there are some who claim that the planets can have an effect. In fact, back in 1974, a book was written about the alignment of planets, the so-called alignment, and this book said or predicted that in 1982, we would have a rare alignment of the planets that would lead to cataclysm. It would lead to earthquakes, floods, the Jupiter effect, as it was called. The planets as trigger of devastating earthquakes, written by John Gribben and Stephen Plageman. They wrote this book in 1974. They were promptly criticized by the scientific media, but not before they sold God knows how many millions of books, made quite a bit of money. And look, how could you go wrong when you get a forward for the book by none other than Isaac Asimov? I'm sure that Asimov got a small percentage of the money that the two authors came. But you know, when you write a book like this, you have problems. You cause other people to try to copy, and sure enough, there were similar books. Earthquake, 1982, When Planets Align, written by a guy by the name of Doug Clark. Did a massive earthquake occur in 19? The planets didn't even align like this. There was no alignment. The planets were in such an arrangement where they covered an arc of about 80 degrees. In other words, roughly, they were in 1/4 of a circle, and they were together in such a manner that that was about as close as you were going to get to an alignment. And Plageman and Gribben, they were claiming that that was going to be enough to pull on the Earth and cause all kinds of problems and mayhem, even so much to team up, all the planets would team up and pull on the sun and cause massive solar flares and sunspots. So ridiculous. I mean, the sun is the leader in the solar system. And so, as a result, nothing happened in 1982. There were no floods, no devastating earthquakes in 1982. And certainly, it didn't seem like we had any kind of changes to our weather. Yet, there are some who still believe that the planets do have a say in our weather. This is one such gentleman. His name is Jim Witt. You may not know him on Long Island, but here in the Hudson Valley, he is revered. Jim Witt, this coming Valentine's Day, will be celebrating 50 years on a radio station up here in the Hudson Valley of New York, WHUD. But Jim Witt has been doing long-range forecasts for many, many, many years. Remember when I told you way back at the beginning, about an hour ago, about Harry Geiss and that prediction that he made about the snowstorm on Christmas Day? At the time, Jim Witt was a teacher at the Lakeland High School in northern Westchester, and he taught meteorology. In fact, many of the people who work at the Weather Prediction Center down in Washington, D.C., were taught by Jim Witt. They even had their own weather station. For goodness sake, Jim was even able to arrange to get a radar, a weather radar system that was going to be decommissioned by one of the weather bureaus here in the Northeast. They were going to get rid of it. He got heard about this and asked them, could we have that radar? And they gave it to him. And so these kids in the Lakeland High School were studying weather at a very young age, getting hyped up by the weather and with the help of Jim's enthusiasm. And so when Harry Geiss in 1966 made that long-range prediction, and it came true, Jim contacted Harry Geiss, explained to him who he was, explained to him what he was doing, and said, could you tell me how you did it? Can you give me an idea of how did you make this prediction? Harry Geiss, and by the way, Harry Geiss was in New York for 1 year. 1 year. And then he left New York. A lot of you probably saying stuff, I don't remember Harry Geiss. He was only in 1966. But he came from California. After 1 year of New York weather, he said, I had it. I can't take this climate. And he went back to California. And so that's why nobody in New York remembers Harry Geiss except Jim Witt. If, by the way, you go to California, Harry Geiss died some years ago. Harry Geiss is as revered in California as Dr. Frank Field is revered to all of us here in the New York area today. Everybody remembers Frank Field. And in California, everyone remembers Harry Geiss and his long-range prediction. So he made a mark, not here, but in California, but he did make that one prediction about the 66 Christmas snowstorm. Jim Witt remembered that. Jim Witt contacted Harry Geiss, and Harry Geiss said, I'm not going to tell you how I did it completely. I'm going to give you some clues, but I'm going to give you an idea of how it's done. And I admire what you're doing for the young people. And if you give you these hints, and you try to do your own research and figure it out for yourself. And he gave Jim some hints. Jim worked on those hints and did his own research. And in 1986, Jim Witt was ready to start publishing his own long-range forecast a la Harry Geiss. And he did that with a calendar. See the calendar he's holding there in his hand? That calendar has been published every year since 1986 and has been offered by Jim and the radio station he works for, WHUD. Now, you may say to yourself, That's fine and good. How much does he charge? He charges a certain amount of money for the calendar. Has he gotten rich? Well, he's made quite a bit of money off of that calendar in all these years. Here's the 2022 version of the calendar with his long range and beautiful calendar with pictures of the Hudson Valley. You see here autumn in the Hudson Valley. But all the money that he has made from these long range predictions, Jim Witt has not pocketed for himself. The radio station hasn't gotten any of that money either. What Jim did was he formed a organization called the Hope for Youth Foundation for young people who, in his words, have been dealt a bad hand in life. All the money that he gets from this long range calendar goes to the Hope for Youth Foundation, which is then distributed to such worthy causes as Ronald McDonald House, St. Jude, many children's charities. Every single cent from the calendar goes to these children's organizations. And since 1986, when he published his first long-range calendar, Jim Witt has made over $4 million single-handedly. And he still does it to this very day. Now, the interesting thing about this is that in the calendars in recent years, Jim has made his predictions. He's already made it. Jim is in his 80s, and he's hoping that he's going to be able to find somebody to make these forecasts after he is no longer able to. He's made these predictions using the Harry Geist methodology, the sun, the moon, and the planets. I asked him once, Jim, how do you do this with the planets? How ridiculous is that? Oh, well, I have my way. I have my methodology of doing that. Okay. So he's made a list of important dates to watch in the future. These are times when we're going to get unusual storminess. And look at this. He's made these predictions all the way out until almost the end of this decade, 2028, for goodness sake. And he phases these up with either the number 1, associated with high energy cycles on the sun. These may feature intense storminess. Or number 2, these dates are associated with specific locations of the sun and the moon, associated with intense storminess, often followed by brisk winds. And number 3, these are the dates with a planetary connection. In other words, these are the dates that he says are influenced by the planets. The probability of rain or heavy thunderstorms in the summer, or clearing and colder temperatures, a cold frontal passage in the wintertime. Well, you want to get out your pad and pencil. These are the predictions that Jim is making for this upcoming year. And notice this knocks me out. January 13th to 15th. Do you remember that? That was last week, just not too long ago. We had a spell of mild temperatures like we had today in temperatures in the 40s. And then came a cold frontal passage, and like a day or two later, temperatures, at least up here in the Hudson Valley, we dropped to 0. You talk about a cold front. Yeah, I would give him credit for that. Now, if you believe in Jim's methodology, he's predicting a major cold front or some kind of a major disturbance right around Groundhog Day, 2nd to the 4th. Then another round of storminess for the 9th and 11th of March. In May, he's got another cycle of a strong cold front maybe moving through, and May 20. Again, I don't know if you believe this. I had not looked at the accuracy of Jim's forecasts, but I respect what he does for the calendar and for what he is doing for young people and all the money that he has raised using the long range. I guess if the calendar was useless, if it wasn't all that accurate, people wouldn't buy it. But people buy it. I know people who swear on his long range forecasts and predictions. If you want to get a copy for yourself, I think it costs like $10 or $12. I'm not sure. Go on Google and go type in Jim's name, Jim Witt, or type in Hope for Youth Foundation. You'll probably be brought to his organization site, and you can probably find a way there to purchase the calendars. I thought I'd do this commercial for Jim, if for nothing else, like I said, for the good work that he is doing for young people and his charities. But I remember I told you just a few moments ago, what malarkey, that the planets could have any effect on our weather or our climate. Well, guess what? Dennis Kent, a very respected Earth scientist who works at the Lamont Earth Observatory, a division of Columbia University, wrote a paper in May of 2018. And in that paper, he wrote, Jupiter and Venus are such strong influences because of their size and proximity. Venus is the nearest planet to us and roughly similar in mass. Jupiter is much farther away, but is the solar system's largest planet. And that's a pretty long stretch here, 405,000 years due to wobbles in our orbit around the sun caused by the gravitational pulls of these two planets, there are seasonal differences here on the Earth. They become more intense. Summers are hotter, winters are colder, dry times are drier, wet times are wetter. So, indeed, I guess I was wrong. Maybe Jim has something with his methodology, or Harry Geiss had something to the influence of the planets, because here, somebody who I would highly respect, Dennis Kent of Columbia University's Lamont Earth Observatory, says yes, in at least a long-term way, the planets, at least two of them, do have an influence on our climate. So maybe I was wrong. We'll see. Now, as I said, I was in the business. I was a television meteorologist for over 20 years at News 12 up in Westchester. And I will tell you that in my 20 plus years on the air, my accuracy, I once told a reporter, I considered that I had an 88% accuracy range. I figured I was right pretty much 88% of the time, which meant, of course, I was wrong 12%. There were times when I had what I called a Gomer pile. And a Gomer pile was that if I predicted, let's say, a coating of snow, I'd go on the air one night and say, tomorrow morning when you wake up, you'll see a coating of snow. You wake up the next morning, what? There's 4 inches of snow. Hey, it happens. And when that happens, I look out the window and I see that happen. I hear Jim Neighbors, the late Jim Neighbors, or Gomer Pyle. I hear in the back of my mind, surprise, surprise, surprise. And you know what? Almost a 90% accuracy range in those 20 plus years on the air. And nobody ever seems to remember that. They only remember the times when you're wrong. That's what weather forecast, all weather forecasts will say the same thing. They come down hard on us when we're wrong. They never say anything when we're right. Joe, you hit that right on the money. That was a great Very rarely did I ever hear that. But when I got it wrong, Joe, you blew it. What happened? You were asleep at the switch, And you know what? That doesn't happen just for weather forecasters. It happens for other professions as well. See this guy? You know who he is? His name is Bill Buckner. Bill Buckner. Bill Buckner, and sadly he passed away a few years ago, but in his prime, you would have wanted Bill Buckner on your team. Bill Buckner was a hitting champion, batting champion. He hit for power. He was a great fielder. He had a wonderful fielding percentage as well. He had 2,800 plus hits in his career. He probably falls just short of the Hall of Fame. And who knows, maybe the Veterans Committee in baseball sometime down the road will consider him and put him in the Hall of Fame. He certainly deserves it. Yes, Bill Buckner, a great ball player from every standpoint. But what is Bill Buckner remembered for the most? He's remembered for this one singular mistake, a ground ball that went through his legs in Game 6 of the World Series, allowing Mookie Wilson to drive in the winning run when it looked like the Red Sox were going to win the World Series. It turned out that the Mets won the game on Game 6. The Mets won the World Series the following night, and everybody blamed Bill Buckner. And he doesn't deserve the blame. It was not just his fault. And he made one mistake in a star-studded career, and everybody remembers him. Whenever you mention the name, everybody remembers Bill Buckner just for this. It's unfair, but in the same way, I say the same thing. When I was wrong those few times, people would only remember the wrong forecast and not the good forecast. So that is what it is to Bill Buckner, wherever he may be now. It is what I would call the weatherman's lament, and I leave this with you tonight. Here is life's great December. Those in the main are our regrets. When we're right, no one remembers. But when we're wrong, no one forgets. And that is it. And I want to thank all of you for coming this evening. I ran a little bit longer than I normally do, but I want to thank you all for coming out and listening to the talk. And now, if you have any questions, I will very happy to answer them on the chat board right now. I'm going to see if I can see the chat here. And yeah, I see this. This is from Colwarn Parmar to everyone. Weather changes several times in a day, even in a few minutes. If study of lunar and solar cycles can predict storms in advance, then why meteorologists have to solve complicated differential equations with the help of supercomputers? Different places on Earth are having different type of weather at the same time. At one place there is snow, at others there are other types. How will you explain this anomaly? Well, I can't. You're absolutely correct. There are different changes that occur across the globe, and we do need those supercomputers to help show us the alignment of the jet stream winds and where these various weather features are going to go. And as a result of that, we rely heavily on those supercomputers. Now, I think if there was anything to sunspots, if there is anything to the motions of the moon or even the planets, and if we could plot them out, not necessarily to try to make a specific forecast, as let's say the Farmer's Almanac tries to do each year, but maybe try to predict a time frame during the specific times of the winter where there may be some specific spell of cold weather or stormy weather, and then use that in conjunction with the supercomputers to try to forecast some specific storm as we get closer to that particular date or time. That might work. But I do know that to this day, whenever the Farmer's Almanacs come out in the late summer and early fall each year to forecast, and they give a summary as to what the weather is going to be like for the upcoming year, you could always see or hear people at the Weather Service or people on television and radio poo-pooing that, saying there's nothing to that. It's no worse than throwing throwing something on at the dartboard. There's no basis. But actually, I think there is. Whoever makes these forecasts for the Farmer's Almanac or the Old Farmer's Almanac, they probably have credible or legitimate scientists who are trying to, do the forecast and using various types of cycles in order to come up with something. And indeed, sometimes you'll hear in the news, Farmer's Almanac gets it right. I don't know how many times they get it wrong, but the publications themselves are interesting and good. They're still very popular. Jim Witt's calendar continues to be popular. So whatever you believe in, that I will leave strictly up to you. Somebody else wrote, is there any possible connection to increase in volcanic activity with decrease in sunspots? I think the two are, according to Dr. Schmidt, the two are totally unrelated. From what Dr. Schmidt told me a number of years ago, the changes in the sunspot cycle have little or no effect on weather and climate. Now, I could point to a number of very credible PhD scientists, for example, who will say quite the opposite. Again, it's a very contentious issue, but we do have proof with major volcanic eruptions in the past. Pandora, Krakatoa, more recently, 30 years ago, Pinatubo, remember that, in the Philippines, which did have a major influence on our weather for the major amount of dust that was thrown up into the atmosphere. By the way, a release that came out just a couple of days ago said that the Tonga volcano, as dramatic and active as it was, probably did not put out enough ash to influence our weather here around the northern hemisphere. So we may not see any changes in the future from Tonga, but we could always have a major volcanic eruption, even bigger in the future, and that could have perhaps an influence in our weather. What computer languages are used? What would you recommend for a high school student, upcoming meteorologist? What are the best courses to take? I am currently finishing calculus. Love meteorology. What publications are good for a high schooler? Well, get WeatherWise magazine. And if you're going to major in meteorology, by all means, the best weather school in the country is Penn State University. If you are good in calculus, in mathematics, if you have a real good, strong background in science, you're on your way. By all means, look into the weather program that they have at Penn State University. They also have weather programs not as good, but still reputable at Albany, SUNY Albany here in New York. Also in New England. Oh my goodness! There's a school in New England where you can major in meteorology, and they have in fact weather gatherings every year in the spring, storm conferences. And in fact, Nick Gregory went to that particular school in New England, and unfortunately just popped out of my head. But by all means, make sure to look up Penn State University. They are the #1 school in meteorology. AccuWeather is located not far away from Penn State. And in fact, if you are a graduate student or if you graduate from Penn State, you can get started at what they call the campus weather service, and maybe get your foot in the door there and eventually work your way into working at AccuWeather. Pick up a copy of the New York Times. The weather forecasts that are done for the New York Times are done by Penn State University, by the people who are at Penn State. So again, that's the thing I would tell you to look up and look into. And again, make sure you get a hold of WeatherWise magazine. Get a subscription to that. That'll provide you with a lot of good information. And one final thing before I sign out here, as if I didn't talk enough already, but if you are interested in weather, as this young man indicated on the chat board, I invite you in a few minutes to go to a YouTube page. The YouTube page is a channel, Joe Chiaffi Weather Channel. Joe Chiaffi used to do the weather on Pix 11, and also, if you remember, a long time ago at News 12 in the mornings, News 12 Long Island. Joe Chiaffi, like I, retired now, and we have a program that we do every night, every weeknight. Usually it's 7:30. Tonight it's 8:30 because I had to do this talk for all of you tonight. But at 8:30, in just a few minutes, I'll be going over to Joe Chiaffi's YouTube channel, Joe Chiaffi, Cioffi, Joe Chiaffi Weather on YouTube. And we do a show on his channel every weeknight called the Joe and Joe Weather Show. Wasn't it nice for him to give me top billing? Or maybe he gets top billing. I don't know. But we do that show every night. It runs for about an hour. We talk about the weather that happened today and forecasts for the upcoming next few days or during the next week. And sometimes we go even further than that, what the trends show for maybe the next month. We have a good following. When we have no weather at all, we still have a couple hundred people who tune us in on that channel every weeknight. And on Sunday mornings, we're there at 11 a.m. We call that Coffee with Joe and Joe on Sunday mornings at 11. But we have a couple of hundred people who watch us, faithful viewers every night. When we have active weather, we go as high as 300, 500, 600. Once we even hit 1,000, when a big storm, like that big snowstorm we had last February, everybody tuned into us to get the first look at what was going to be happening weather-wise. So we figure that we're the place to tune into. You watch your local TV weather guys on, the local TV channels, but they're only on for about a minute or two or three. We're on for about an hour, sometimes even longer. And we have guests. We've had Bill Corbell from News 12 Long Island, now retired. The Jim Witt, who I mentioned in my talk. We had Lonnie Quinn on about a month ago, who came on our channel. We had some people from the National Weather Service, Bill Goodman, one of the lead forecasters for the National Weather Service here in New York. So I invite you, again, in just a few minutes, tune into Joe Chiaffi's YouTube channel, where Joe and Joe, the Joe and Joe Weather Show, will be on. And you could also go to my Facebook page, Joe Rao Weather, Facebook, and I usually provide a link to the Joe and Joe Show each night on my YouTube channel. So you can go there, you can go to Joe Chiaffi's site. But again, I want to thank you all for your questions, and I hope that you had an interesting evening listening to me jabber on about weather and astronomy or whatever. And I hope perhaps to come back and talk about other subjects. There's going to be a total eclipse of the moon in May. Maybe I can come back and talk to all of you about that, or a big meteor shower coming at the end of May, or other subjects. Again, I offer these services to libraries throughout the tri-state area. I hope that perhaps I have a chance to come back in the future to the Middle Country Library to give all of you another interesting weather or astronomy talk.
We will
I thank you.
absolutely have you back. We will absolutely have you back. This was fantastic. Thank you so much, Mr. Rao, for presenting tonight.
I thank you. I thank all of you, and have a good evening. And again, bundle up. It's going to get cold in the next few days.